All right, everybody. It looks like we are in lesson 3.8, which is on slope and equations of lines. And if you are anything like my students in geometry, that is the dreaded S word, slope. And I get two reactions. Either you thought it was super easy, or you just despised it. It's never in between. But we are talking about slope, you guys, and you're going to talk about slope in algebra 2, and you're going to talk about slope in all your other math classes. It is a part of life. And let's just face it, it really is. You've got pitch of roofs, you've got grades of wheelchair ramps. Yeah, slope is here to stay. All right. So let's see. Slope is the ratio of change from y to x. And if you've heard rise over run in an algebra class, here it is again, rise over run. All right. So we got slopes of parallel lines and slopes of perpendicular lines. Okay, interesting. I bet we're going to have some slopes of horizontals and verticals come up too. All right. So let's just get into this. All right. So we got example number 1. And we are in, again, 3.8, which is slopes and... Sorry, you guys. My phone's been dinging, dinging, dinging. All of a sudden, I'm getting bombarded by stuff. My apologies. So it says A, B, and C, D are parallel, perpendicular, or neither. All right, we got A, which is 3, 6, B, and negative 9, 2, C, which is 5, 4, and D, which is 2, 3. All right, we got to graph the line. Okay, well, it looks like they did the math for us. Here's your slope equation. Y2 minus Y1 over X2 minus X1. And we're going to take the second Y in the AB and subtract the first Y in the AB. All right, so looks like we're going to, okay, I guess they did it backwards. All right, they did Y1 minus Y2, and that's fine as long as you're consistent. 6 minus 2 goes on top. And then on the bottom, 3 minus a negative 9. Watch out for that double negative, you guys, because it's going to change to a plus. And 4 divided by 12, because 6 minus 2 is 4, and 3 plus 9 is 12. It's going to simplify. It's going to simplify down to a fraction of 1/3. All right, same thing for slope of CD. So we're going to take our 5, 4, and 2, 3, do the slope formula. So 4 minus 3, those are your change in y, on top. And 5 minus 2, the change in x is on the bottom. 4 minus 3 is 1. 5 minus 2 is 3. So we have a fraction of 1/3. Now here is something you need to pay attention to. They have the same slope. And if they have the same slope, then the lines are parallel to each other. Now, I don't know about you, if you're a teacher, geometry teacher, I have a lot of visual learners in my room. So I'm going to open up this GeoGebra over here. And if you have a lot of visual students in your room, this is not a bad idea to actually show them. I'm going to graph these two, A, B, and I'm going to graph CD, and I want you guys to look at them. So A is 3, 6, and B, negative 9, 2. So this is what GeoGebra looks like when you open it up. Do not open up the GeoGebra calculator. I'm actually in GeoGebra Classic. Over here is where your input is. You've got two ways of plotting lines. You need to go to the point and pull down and actually plot the ordered pair as you want, or you can click in the input and label your ordered pair A at 3, 6. So make sure you put a comma in between and hit enter, and it gives you the actual coordinate. Now you probably can't see it because over 3 and up 6 is off the graph. So I'm just going to move it down a little bit so you can. All right, so B is at negative 9, 2, looking right here. Come back over, put in a B, negative 9, comma 2, hit enter. And again, negative 9, 2, you probably can't see it because negative 9 is left, not up 2. So I'm going to move this out so that you can see. And there it is, you guys. I'm going to draw a line between B and A. Your line tool is the third icon. Click on it, pull down line, click on B, click on A. There we go. We got our line. I want you to notice they give it to you in standard form. Negative x plus 3y is 15. Standard form is ax plus by equals c. But I'm going to show you a little trick to find the slope here in a minute anyway. All right, going back. CD. C is at 5, 4. D is at 2, 3. So 5, 4, 2, 3. C, 5, 4. D is 2, 3. There's my 2 points. And again, I want to draw a line between them. So I'm going to go click on D, then C. And I want you guys to notice that I've got my standard form over here. So if I put this in slope-intercept form, you're going to notice that the slopes are the same. But if you don't want to do all of that, look at this little icon right here. It looks like an angle. Click on it. The 5th one down says slope. And over there in the bottom corner, you see select line. So I'm going to click on slope. I'm going to click on the line AB. Boom. There's the slope of 0.33. I'm going to click on the line CD. Boop. Same slope, 0.33. So these are, in fact, parallel lines. So these have the same slope. They are parallel. Parallel lines have the same slope, everybody. You need to know that. All right, we've got to check here. It says determine A, B, C, D are parallel, perpendicular, or neither. And they want us to graph. All right, well, do your formula, y2 minus y1 over x2 minus x1 for AB. Same formula for CD. And they want us to graph it. So, yes, I'm going back to GeoGebra. I'm going to get all of this out of my way. So I'm doing everything. All right, so here we go. A is at 1413. So I'm going to change this. Actually, get out of all of that. A. 1413. Don't forget to hit return so it pops in there. All right, there it is, 1413. And B, negative 11, 0. B, negative 11, 0. Return. I'm going to connect those with a line. The third icon over and line. Click on A then B or B then A. Doesn't really matter. There's my equation. Next up, C, D. C is negative 3, 7. Coming over here, C, negative 3, 7. And D is negative 4, negative 5. Negative 4, comma, negative 5. And hit enter. Oh, well, they're definitely not parallel. And if you're a visual person, connect those. They're not parallel to each other. They don't run in the same direction. They're not equidistant from each other. There's your equation. Most definitely not parallel to each other. Now, the question is, are they perpendicular? Well, I mean, look at it, you guys. Is this angle, does it look like it's 90 degrees? No, it's not. But if you know me, and some of you guys do because you're in my class, I have a little trick I want to show you guys. It's the 4th one over. No, I lied. I lied. It's the first one over. See that word intersect? I'm going to click on it. Now what I'm going to do is I'm going to click where those two lines intersect each other, and it's going to give me a little black point, and they label it E. You notice that these others, the A, B, C, and D are blue. The E is always for your intersection. What I'm going to do is I'm going to look at the angle of this. Well, either all 4 of them really, because if one of them is 90, all of them are. Click over to your angle. Click the first one down. Now, if I remember right, because it's been a minute, you have to go in a clockwise motion. So around, I'm going to click on A, then E, then C. And it's going to give me this lovely little number that I'm going to move to show you that it's not perpendicular. You guys, perpendicular means it has to be a 90-degree angle. And that 57.76 is not 90 degrees. So these are not perpendicular. They're not parallel. This is a neither. So this is a good point in time to actually go through what makes perpendicular. You guys, they have to have opposite reciprocal slopes. So parallels have the same slope, but perpendiculars have to have opposite and reciprocal slopes. What I mean by that is one of them has to be a positive number, the other has to be a negative number, but they had to be flipped upside down as well. So if this was a 1/3, to be perpendicular, the second one had to be a -3. That's what opposite reciprocal is. So this is a neither, because that angle is not 90 degrees and they are not parallel lines. All right, let's move on. Example number 2. Determine whether the lines are parallel, perpendicular, or neither. Well, just by looking at it, they look perpendicular. But I'm not sure until I do some math on it, so let's check it out. All right, here's your slope formula, y2 minus y1 over x2 minus x1, and they do RS for us, which is super nice. There's RS, and so they do 7 minus your -3, because those are your y values that go on top. 6 minus -8, because those are your x values that go on bottom. Don't forget your double negative is a plus. 7 plus 3 is 10. Here's another double negative. 6 plus 8 is 14, and simplify to 5/7. Well, look at this. They set this one up for me too, for TU. There's T and there's U. They do 0 minus the 6 on top, and 0 minus 6 is a -6. 0 minus a -4 on the bottom, which is a double negative. It's going to be a plus. So 0 minus 6 is a -6, and 0 plus 4 is a +4. I think they forgot the negative right there. That's why I'm kind of like, look at this going, yeah, something's not right. So -6/4, because 0 minus 6 is a -6. So -6/4, the question is does it simplify to be a -7/5? And, it does not. So a -6/4 will simplify to a -3/2. So, yeah, they're opposites. That's true, but they're not reciprocals of each other. This would have had to have been a -7/5 for it to be perpendicular. So it looks like it's perpendicular, but if I were to put this on GeoGebra, no, it wouldn't make a 90-degree angle. Okay, so looks like it's neither on this one. Let's see what's going on here. Okay, okay, it's just answering it. I got you. So negative, so neither. All right. Let's see going on. EF and DG. All right, so EF is here. DG, again, it looks like it might be perpendicular, but as you can see here, it looked like a perpendicular, but it ended up not being. So I don't know until I do the math or get GeoGebra to kind of take a look at it. All right, so EF. All right, so they do -1 minus 6 on top and 6 minus 3 on the bottom. All right, so -1 minus 6 is a -7. 6 minus 3 is 3, so I'm looking at a -7/3. All right, so to be parallel, this would have to be the same thing, a -7/3. To be perpendicular, I had to have a positive 3/7. All right, well, here we go. DG. All right, on the top, we got 5 minus a -1. Double negative makes it a 6. We've got 12 minus a -2 on the bottom. The double negative makes it a 14. 6/14. We have to simplify that. Okay, I'm going to divide them both by 2, probably the easiest thing. So 6/14 simplifies to 3/7, and it's positive. So it looks like to me these are actually perpendicular to each other. I have one negative and one positive. They are opposites. A 7/3 flipped upside down is a 3/7. They are reciprocals. Opposite reciprocals, you guys. They are perpendicular. Okay, so the two lines do not have the same slope. So they are not parallel. Determine whether the lines are perpendicular, find the product of their slopes. Oh, okay, so they're going to have us check it. What I mean is they're going to multiply these two things. That's what product means. So a -7/3 times 3/7. When you multiply that, you get a -1. Now it's going to make me put it in here. Interesting. All right, so because their product's a -1, the two lines are perpendicular. That's a good way to check it, by the way, if you want to do that. All right, determine whether they are parallel, perpendicular, or neither. Oh my gosh, look at this. Easy, easy, easy. This is a horizontal line, AB. This is a vertical line, CD. Horizontals and verticals are always perpendicular. Perpendicular, automatically. By the way, horizontals have a slope of 0. Vertical lines have undefined slope or no slope. Oh, it looks like you've got an online thing, an online activity. You're more than welcome to thumb through that if you want to. All right, let's move on to the next. Okay, I see what they're going to do with this. So instead of looking at ordered pairs, they want us to look at equations. All right, so one more time, parallel lines have the same slope, the same m's. Their y-intercepts can be different, but they have to have the same m to be parallel. If they have opposite reciprocal m's, that is perpendicular. All right, okay, here we go again. Look, I said it just a minute ago. Horizontal, vertical, automatically perpendicular. Example number 3. Here's my slope 3. This is in y equals mx plus b. You guys, we call that slope intercept form. This one's in what we call point slope form. But it's still, the slope is right there, -1/3. So ask yourself, are they the same number? No. Are they opposites? Yes. Are they reciprocals? Yes. So these are perpendicular. All right, so the two lines do not have the same slope. The lines are not parallel. Remember, the lines are perpendicular. Well, yeah, they are, because their products, like 3 times -1/3 is going to end up being a -1 when you multiply them. So these are, in fact, perpendicular. Because the product of slopes is -1, the two are perpendicular. Opposite reciprocal slopes. All right, part B. Look at this. Y equals 3 is horizontal. X equals 1 is vertical. Horizontal and vertical are automatically perpendicular, everybody. Moving on. These are both in point slope. I'm sorry, no, they're not. This is point slope. This is slope intercept. Doesn't really matter. That slope is a -3/4. This slope is a -3/4. So ask yourself, are they the same slopes? Well, yeah, they're both -3/4. So because the slopes of both lines are the same. Whoa, get back here. What? What do you want me to do? Oh, you want me to actually put the number in. Fine, -3/4. All right, so they're both in -3/4. All right, so the lines are parallel. All right, part D. All right, slope is 2. Slope is a 1/2. They are not the same number. So the two lines do not have the same slope. So the lines are not parallel. All right, perpendicular. Well, they're reciprocals, I agree, but they're not opposite reciprocals. They're both positive. Look, there's a +2. That's a +1/2. If I probably multiply that and get a +1, not a -1. So, yeah, these are not perpendicular either, because the products of the slopes are not -1. The two lines are not perpendicular, so the two lines are not parallel, not perpendicular. It's neither one. Oh, look at this. Now they're both an x. Okay, x equals a -2 is vertical. X equals 4 is vertical. We've got two vertical lines. Both lines are vertical with undefined slope. Vertical lines are always parallel. All right. All right, so it looks like you got an online activity. I'll leave that to you. Okay, check. Maybe I should leave this to you too, but I'm not. Parallel means same slope. Perpendicular, opposite reciprocal slopes. And if neither one of these hold true, neither. Slope is 3. Slope's a -1/3. Are they the same? No. Are they opposite? Yes. Are they reciprocal? Yes. These are perpendicular. Slope is 9/7. Slope is 9/7. Are they the same? Yes. They are parallel. All right. Okay. This is a vertical. Vertical x equals -3. This is also a vertical. X equals 4. Vertical lines are always parallel. Example number 4. Okay, get up on the slope of the line. They do some of the work for me. I love this. Okay, y is on top, -6 minus -2 on top. Watch out for that double negative. On the bottom, 0 minus -6. Watch out for that double negative. All right, -6 plus 2 is a -4. 0 plus 6 is 6. And we need to simplify that. So a -4/6, and we're going to need to simplify that. So -4/6 to a negative, get in there, -2/3. All right, let's see here. Because -2/3 and 3/2 is a -1. The slope of the line perpendicular to QR through P is, okay, so the slope of the line perpendicular to QR through P, well, the slope's going to have to be a positive 3/2. So positive 3/2. I love when they do part stuff for me. It just makes my life easier. All right, so let's move on. Got an extra example. All right. Okay, example number 5. All right, looks like we are running an equation that is parallel to y equals -3/4 x plus 3. That means I got to use their slope. Parallel lines have the same slope, so whatever their slope is the slope I have to use. So I'm going to use the -3/4 as a slope running through -3/6. All right. Okay, so parallel lines have the same slope. That means whatever their slope is, my slope is. So the slope of the line parallels in -3/4. So I'm going to use -3/4. All right, so they use y equals mx plus b. That is not my equation of choice. I always use point slope. But like I said, most of my students are visual people, so they just see it better. But that's okay. We are going to do what they've got. Y in your problem is the 6, so they replace it with 6. M in your problem is the -3/4, so they replace it with -3/4. X in your problem is the -3, so they replace it with -3. And we need to find B, which is your y-intercept. So it looks like to me, get away from there, they need to multiply -3/4 times -3. Well, first off, a negative times a negative is a positive. 3 times 3 is 9. And on the bottom, 4 times 1 is 4. So it's going to be a positive 9/4. All right, and the opposite of adding is to subtract to either side. So I'm going to take 6 and subtract 9/4. Do this on my calculator. I got 15/4. 15/4. So the equation is y equals, remember I got to use their slope, so it's -3/4 x. And then plus 15/4 for our y-intercept. All right, there you go, you guys. Got another online thing. And listen, I have got to go, so I'm going to leave this to you. Your check is on you, and I think the practice is coming up. So try that out yourself. Look, you got some instructions here. Ask your teacher. We are happy to help. That's why we became teachers. But ask me a question if you need to, you guys. I've got to go because I've got to meet somebody. And yeah, I hope you guys have a great day. We'll talk to you later.